thank Charlie Bird for co-sponsoring this with the IEEE. So thank you, Charlie. First things first, bathrooms. It's not easy to find. You're going to go outside the double doors you came in. You'll make a left, go all the way down the hall, and then you have to go up one level on the escalator because they're doing work on this level's bathrooms. So all the way down the hall, elevator up one floor, the bathrooms are right there. So very important. This facility is provided to us by Corporate Alliance. Corporate Alliance is an organization that I belong to that is about learning, serving, and growing. And the idea is you want to learn about people in your community, and you want to figure out how you can serve those people. And in the way you serve those people is how you will grow. And so it's a networking organization, a little bit like Vistage or some of the other ones that you might see out there for UCEO types. But the entire reason for it to exist is for serving other people. So one of the ways that we at Telarus serve is we provide things like this where we can teach other people about RFID and how it works. I'm going to let Charlie speak a little bit about IEEE, and then I'll get into the main event. So give me a second while I transition to his presentation.
Thanks, David. My name is Charlie Bird. I'm the chair of the Computer Society here in San Diego. No, I don't know anything about it. My job is to bring meetings like this and find what you need to find, whether they expect you to or not.
You can go around the back really easily to get to the other side. So there's a hallway behind this. I'm sorry, Charlie.
Okay.
Just if any of you on this side need to get to this side, instead of walking through, it's really easy just to go straight down the hallway.
Cool. No problem. So we're the largest professional organization in the world since 430. We're really about 450,000 people, 160 countries, 4,000 sections. I'm not going to read all this. We do the National Electrical Safety Code, certified universities. Matter of fact, our boss here in San Diego just went back and certified Syracuse University, electrical engineering and computer engineering, my old alma mater. The Computer Society, this is the next slide, is we have 60,000 members. We have our own website, blah, 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 blah. And one of the nice things about the Computer Society is they have a huge online learning facility. It's huge. It's terrific. There's a lot of things in there, and you can pick up all kinds of really fun things. And we do big data security, hundreds of conferences each year. You've probably heard of some of our conferences. And for the San Diego section, I'm going to ask, I want you to get an idea of how many people here are IEEE or unmanned systems professionals. Call that. Okay, so here's what we got coming up. December 6th, a bio-inspired machine learning. That's with Stay War guy. This is going to be very good. You should, it's a 6th and maybe 7th age. What can I tell you? It wasn't my fault, someone else did. And that's also going to be limited to 100 people. So if you want to sign up for that, I would suggest you, because otherwise Stay War will fill it up themselves.
I zoomed in a little bit on the dates on the screen, so you should be able to see.
Beautiful. So, yeah, so that's going to be, it's less than a week.
All right. So, I've been working with RFID, and next year will be 25 years. It kind of surprised me that I've been working in it that long, and that it's actually been around that long. 25 years ago, my dad came to me and said, we have a cousin of ours in Chile has some cattle that he's trying to track, and there's this cool new technology called RFID. Do you want to take a look at this stuff? And so, having just graduated from Caltech in my first couple of years in grad school, I dove into it and actually built a little program, and it was neat. And I kind of fell in love at that point with RFID. So RFID, everybody here, does anybody not know what RFID stands for? It just came for the free food. Good. So radio frequency ID is just, it's a way to identify things. After I graduated with my PhD in bioengineering, I actually stayed with the company that I was working with at the time, Cubic Corporation. I think we have at least one person from Cubic who was supposed to come. And I worked with their go-kart team. At Cubic, we were working with the WMATA, Washington Metro Authority, to put in a contactless smart card. And I was part of a fabulous team under Joe Ravenis and Guy Kelly at Cubic, where we developed the card, the crypto, the antenna, all sorts of cool stuff. I was just very blessed to have fallen into that situation and learned a ton about this situation, about RFID and how it works. So I've got this background in just generic engineering, and I fell into RFID. And so for all of you RF guys out there, you know a lot more about the RF than I ever will. I'm more of a high-level applications guy. I know enough to be dangerous about the low-level stuff. So I worked with Cubic for 10 years, stayed there till 2005. In 2005, with a friend of mine, we started Teleris. And we started with the idea of using RFID for cool and innovative products for projects that were smaller than 3 million. Cubic said, you know, anything lower than 3 million, we don't want to touch. And we said, you know, there's plenty of room at the bottom. So we started getting into doing RFID for smaller projects, and we've been doing RFID ever since. So again, thank you for coming. I'm going to start off with a little video here. This is one of the RFID projects that I was able to work with was the deployment of the Oyster card out in London. And a few years back, Barclays jumped onto that contactless bandwagon. And let's see if I can bring it over here.
Take it, babe.
One second. The best commute home ever. First use of contact is right there.
Contactless technology from Barclaycard, making payments simpler.
Anyways, so, and that read, as he was going by that reader, took exactly 100 milliseconds to read that contactless smart card, read data from it, and write data back to it. So, kind of a neat tidbit. So, what is RFID? It's basically a way to identify something. It's an electronic chip that has an antenna embedded. It is attached to an antenna, and then it's embedded into some sort of substrate or tag to identify something. Whether that's identifying money, identifying people, identifying assets, animals. They come in all sorts of shapes and sizes. I was explaining RFID to somebody that I was sitting next to on a plane recently. And I said, you know, I bet you have an RFID card in your wallet. And they pulled out their wallet, they pulled out their Costco card. And on your cards, you can see it right here, you have that little wave on, and in your credit cards, that means it is a contactless credit card. It is an RFID chip. If you have a Metro card a Compass card for the San Diego Trolley, if you have a US passport card or a passport, or if you do any work for the federal government, you have an RFID card in your wallet. There are people out there that actually sell for like 20, 30 bucks. A little sleeve you can put your contactless smart card in so your data won't get stolen without you knowing about it. And yes, that does happen. You'll see a little bit more about that a little later in the presentation. The generic RFID system, regardless of what you're doing, has 4 components more or less. You've got your tag that's attached to an antenna. That tag is read by a reader. Sometimes that reader has a separate antenna to read the tag, sometimes it's an integrated reader. That reader is controlled by some sort of middleware. Sometimes that middleware is in a small embedded Linux box, again attached to the reader. Sometimes it's a PC computer, sometimes it's some device out on your network. And then that data gets pushed out to some sort of enterprise system that lets you manage whatever you're trying to manage. Those people, those assets, whatever they are. An easy way to see this is if any of you work for a large company. I heard somebody was working for Viasat over there, I think. To get in your building, you probably have an access control card. RFID card, you have a reader with an antenna built in. It's talking to an access control panel. That's your middleware, and it's managed by your access control system. That's your backend, that's your enterprise system. So every RFID system out there pretty much has those 4 components. RFID gets used in lots and lots of places. I'm not going to read all of these, but just it gets used in places you don't usually expect, and sometimes we don't even think about. Half of you out here, I bet, have an RFID reader in their pocket. If you have a Samsung phone, you have an RFID reader in your pocket. So this is just a standard S5. If this is one of our products, it's called I call it Blinky or Flash RFID. It's got can you guys see that light flashing in there? This card is stealing energy from the RFID reader in the phone to light up that LED and to actually send data to my smartphone. So if you were closer, you could probably see the little number on my smartphone. So half of you out there have an RFID reader in your pocket.
What other phones have the readers besides that 10% stuff?
What other phones have readers?
Exactly.
Some LGs. All of the iPhones have an RFID reader in it. It's not open, but if you've ever used Apple Pay and you have anything newer than an iPhone 5S, you have an RFID chip, an RFID reader in your phone. The Apple one is just not open for public usage. Android is built so that you can interface and develop apps directly on it. But that RFID reader does not read every RFID chip, and that's what we'll be going through in this presentation. So here are RFID tags. So for you real RF engineers out there, RFID works in the ISM bands, so industrial, scientific, medical, approved bands. There are 3 areas for typical RFID that you'll see tags out there that are being used. There's it says 124 to 134 kilohertz. It's actually about 118 to 144 covers a broader range of the tags. The 13.56 megahertz range, and then the 800 megahertz range. You have a question, sir?
Yeah, about 10 years ago, I got really interested in Zigbee, and from what I remember, Zigbee operates around in the 10 kilohertz range. Can you fill me in on what's going on with Zigbee these days?
So, the last time we deployed a Zigbee system was around 2012. So my information's a little bit dated on Zigbee. Zigbee actually operates on a similar frequency as your Wi-Fi networks, and then it modulates down to 10 kilohertz.
Oh, okay, so I
So-
wasn't entirely wrong. All
Right, so so the data gets sent over a modulated signal.
Okay.
Feel free free to ask questions. I love questions. I often learn as much as I can share my information. So for access control, you're going to see people using stuff all over the spectrum. Personal access control started at 125 kilohertz. It moved to 13.56 to be more secure. If you're using vehicle stuff, you'll see it up here. The stuff that you see at like Walmart, that sort of RFID is being used at the 915 megahertz for identifying many, many items. And there are really two classes of RFID. There's an RFID that's called active. An active RFID, your phone effectively is an active RFID device. It has a battery, and that's really the definition of an active RFID device. It is an RFID device that can identify you that has a battery. Yes?
My question is regarding coexistence with Wi-Fi or BT in the ISM band. So, does that have information?
So there are different RFID signals that they are built to coexist with Wi-Fi. There are some that actually operate, so going back to here, there are some RFID at the 2.45 gigahertz and the 5.8 gigahertz that do interfere with Wi-Fi. So you need to make sure that they don't, that either the frequency hopping is set appropriately, or that you are using a different frequency that's not going to interfere with your Wi-Fi. Now, of course, Wi-Fi now has both 2.4 and 5.8, so it really it gets a little tricky. And really, that's why our company exists, because we deal with the tricky every day. So the other interesting thing is there are many RFID tags that operate on the Wi-Fi network. So, and I'll discuss those in a little bit. So again, two classes of RFID. There's active, and then there's a passive RFID. So when we were deploying the Go cards for Washington, D.C. and Chicago, those chips had no battery in them. They basically parasitically took energy from the field, whatever the reader was outputting, it turned that energy into enough amperage that it could actually do whatever crypto stuff it needed inside, and then it modulated the field back to the reader. So those are passive tags. You'll see that active tags can have anywhere from a few inches to miles of range. Passive tags, the longest I've seen a true passive tag work is 39 feet. People keep trying to get it up to that 40 feet, but unless you are putting out enough RF energy to cook somebody, you can't get longer than that.
Question.
Yes, sir.
So do the passives ever transmit, or do they only interfere with existing?
Thank you. So the next slide. So there are two. So passive RFID has a couple of different ways of operating. It always needs to siphon enough energy out of the field to be able to operate a circuitry. Sometimes at that point it'll say, okay, it'll just sit there and say, okay, I've juiced up and now I'm listening, waiting for you to send me data. For contactless smart cards, what they do is they actually answer with an answer to reset. So it says they've answered, their circuitry is reset, and it says, here I am. And then the reader can start the communication. There are other tags that it waits until it sends out, the RF signal sends out a wake-up command or a read data or whatever the command is before it'll send data back. So it works both ways. Let me get through this slide and then I'll come to you. So with with passive RFID, the antenna is feeding energy into the field. The tag will sleep until it gets enough energy. And then once the signal's reached, the tag is ready to listen or speak. With active RFID, they can also work like this, but more often, the tag is sitting there saying, I am here, can anybody hear me? And most of the time that falls on deaf ears until it gets within the vicinity of a reader. And once that can be heard, the the reader knows that the tag is in the vicinity and it can do something. Open a door, open a trap door, send data to a database, whatever. So you have a question.
The passive device, does it collect energy and then transmit it on its own, or is it more like a field modulation?
Yes.
Does it just take the field, the existing field, and
Yes.
it modulates and stuff?
Both.
Okay,
Depends on the tag.
okay.
On the active tag?
Yes.
Can you set how often it,
So active tags are often called beacons. Kelly told me to put this in the presentation and I forgot. So active tags are often called beacons. So they're out there and you can set them so that they can beacon once every second. You can set them so they beacon every 10 minutes, or you can say it beacons once a day. And that has a direct impact on the battery life. And we'll be getting more into those. Let me move a little bit forward because a lot of your questions will be answered. Got a lot of stuff going on. So there's a bunch of benefits to RFID. You have a huge amount of laundry. You can pass an RFID reader by it, and you can read all 250 pieces of those laundry in under a second. So super fast reading. You can do really neat crypto stuff. So you can have the card have its own crypto engine. You can do symmetric crypto for those of you that are more computer science, or you can do public-private key encryption. Depending on what you're looking for, you can set the range of these RFID tags to be just centimeters, or the technology, or you can have it work up to kilometers. There is a tag from Fujitsu that has that's literally, the chip is this big and the tag is about that big, that has 10 megabytes of RAM memory on it, so it's very fast, so you can store a lot of information on this. And think about Flash. They're starting to put things like Flash onto these chips. They use FRAM because FRAM has lower power requirements and Flash has much higher power requirements. You have to get above a certain voltage and current to drive a Flash. You can use RFID to improve counterfeiting. But the most important thing is, in some way, people are looking for some sort of return on their investment using RFID, some way to improve their operational efficiency or their security or their safety. And you might not get all of this with one tag because every type of RFID has some sort of limitation. Let me say that again. Every type of RFID has a limitation. So the LF is low frequency. LF, low frequency. This is used all over the world for animal tracking. Most of the cattle and beef industry uses LF. They have the cows go through these gates, and as they go through, they register what cattle they have. They track them basically birth through death. If you have a card from HID that's kind of a double thick card, that is the LF card. One of the great things about LF is they have a fairly limited range. They work really well around people, animals, and metal. So you guys think about a Faraday cage that can completely block RF. It's 125 kilohertz works pretty well near metal. All of the LF tags are an inductive tag. So that means you have something like this. It's a coil that's tuned at somewhere around 100 to 150 kilohertz that is able to pull energy from the field. The way these tags work, to answer somebody's question earlier, is it literally, I'll share all these slides with you if you want afterwards. So that way you don't have to take pictures. The field, so they'll suck more or less energy and the reader will detect how much energy is being sucked out of the field. So if you look on it on an oscilloscope, what you'll see a normal signal, and then as the tag clamps, it's basically amplitude modulated. There are other tags that do FM and other types of modulation, but for the most part, these are just doing AM modulation over the RF field. And all these different tags, you've got watches, key fobs. If you guys have seen, there was a speed pass by Mobile years back. All LF tags. And they come in all sorts of different form factors.
I noticed in the previous slide you had inductive. Now, how do you get inductors? Like a coil?
That's exactly what this is. That's your coil. So in all of these tags, there is some sort of coil. So on most of these tables out here, so let me first tell a joke. Do you guys, what do you call cheese that is not yours? Nacho cheese. These tags on your tables, nacho tags. Leave them for us. But you open up the bag, take a look at them, you're going to see HF, LF, UHF tags in all sorts of different form factors. Yes?
I have a question, sort of goes back to your earlier slide.
Sure. Which one?
This one's good.
Okay.
I work a lot with vehicle tolling, and in the world I've been in, they're always very specific, even when they're talking about MyFair and cars. Sure. Distinguish RFIDs and okay, that's you call RFID everything.
I call RFID everything that communicates over radio to identify something.
Okay.
And
Is that an industry standard, you think, or is that?
I think that's an industry standard, but there are people that clarify. There's some people that clarify to say that they're working on one technology or another. There are so many types of RFID, it gets very confusing. It gets really hard to talk over you. So HF is high frequency, LF low frequency, HF high frequency. There are two standards out there that operate over 13.56 megahertz. There is the ISO 14443 standard, and in that standard there are actually two different standards, subpart A and subpart B. And there is an ISO 15693 standard. The ISO 14443 standard was built with transit in mind to do very close authentication, two-way crypto over no more than 10 centimeters. ISO 15693 was built as a replacement for the 125 kilohertz with a little bit more information. So those can operate up to a meter depending on how the tag and antenna are implemented. And as you can see, this also is an inductive technology. You can see coils here. So you can see a coil here. Inside these cards are coils. And again, you get them in all sorts of form factors. One of the neat projects I had the opportunity to work with while I worked at Cubic was we were one of the first people to embed an RFID chip into U.S. passports. We got to work with the government printing office with the big presses and find out how much pressure would actually break that chip, because these passports are getting bent around these big, and the U.S. government wanted to use a 32 kilobyte chip, which was in EEPROM was actually pretty big. So we had to be sure to back up very thin so it had a little bit more flexibility so it can go around the rollers without cracking the chips. If you have a U.S. passport or any other passport from most industrialized nations, it has been certified by ICAO, the International Civil Aviation Organization. Why aviation has to do with, I'm not sure. It's been certified by ICAO to work on contactless readers. I'll be talking a little bit more about passports in a little bit. RFID smart cards. The Costco card that you saw earlier, that is a 13.56 megahertz card. Most of the government cards are also 13.56 megahertz. I'm going to see if this works. There's a problem with this.
And Walt disagrees. They're wrong.
So, when they first implemented contactless technology in credit cards, so everybody realizes that now all the new chips have been issued with all the new credit cards have been issued with a chip, right? Previously, about 50% of the issuers were putting contactless technology in their cards. That's been taken away. Why was it taken away? This is going to explain why.
Take a look at this. With permission from a credit card holder, Walt is taking information lifted from a radio frequency credit card and copying it onto his hotel room key. And watch what happens next. He takes the room key to a restaurant and he uses it as a credit card.
Did I just see what I thought I saw? Yes. Yeah, we took what we scanned from that card, put it on my hotel room key, and just walked over to the store, swiped it through, made a purchase. Nobody even asked any question why it was a room key. We've done it at big box retailers for several $100s.
So, when they first implemented this technology in credit cards, they didn't think that people would be walking right by, and all you need to do is have the RFID reader in your cell phone and bump against somebody, and if your phone beeps, it's read that number, and more importantly, it's got the CVC code that's automatically transmitted by that card. So this is one of the cases where it makes more sense to actually have a two-way crypto before it sends to CVC. The credit card companies didn't choose to do that. And no, it wasn't. There's no price difference. It was truly just poor architecture. So the credit card. So credit cards have an issue. So the reason why they took this out, and the reason why there are lots of people out there selling these little sleeves that you can put your credit cards in to protect them, and most government, if you get a government card for doing any sort of government work, and maybe the people at GA, if anybody's from GA here, they issue their government smart cards inside a protective sleeve, so it can't be read through the mail, and they suggest that you keep it in your wallet and only pull it out when you need to use it for access. Just interesting. So you got a question?
Did you say the Costco cards have some sort of RFID chip on them?
The Costco cards do have an RFID chip, and they have improved the integration. That's not a Costco credit card.
That's the credit card.
It's not.
No, that's the membership card.
Okay. My mistake.
Yeah.
Just thought I'd ask.
There you go.
There you go.
And
All right. So, where else do we see a lot of RFID using HF, high frequency? Well, like I said, government smart cards. Hospitals use them to. If you go to most hospitals, and there you go.
Government issued card.
Government issued card. So that is interesting because the U.S. passport card is not HF. The passport is HF 13.56. This card, I was one of the principal architects on the San Ysidro Century program. They use these passport cards and the Century cards for pedestrian access. So if you pull out your Century card and you walk through the pedestrian access, they have readers out there that picks up your card. It then goes and pulls your database record and it starts to do facial recognition. If it's actually done facial recognition before you get to the front, it'll automatically let you through. If it hasn't been able to certify you for facial recognition, you have to put down your thumbprint to using pedestrian access.
This is a Visa debit card. Now, is this an RFID chip?
If it has that little wave thing on it, it is. You can't tell just by looking at it. We have a high-power lantern in the back that we can actually look through the plastic and see if there's an RFID chip. But I can't tell just by looking at it, and I don't know.
It looks like it is, though.
If it has the gold chip, all new credit cards are being issued with those gold chips without any RFID. It's just a contact chip that's put in there for better security measures. They've been using them in Europe for 20 years. They're starting to push them out to the US because we're having so much credit card fraud. The other place HF gets a lot of traction is in libraries. They can use a pedestal reader like this that can read about a meter. So you have two of these, and as you go out, the ISO 15693 standard is built so that it can do a very fast inventory of a whole bunch of items, and it works very well it works well with human body, so it'll read right through your hand. You can cover books up, and a reader like this will read 15, 20 books, and if you have one that didn't get checked out, it'll beep and alert you.
So, do they chirp at random times, or?
No, this is a big inductor here that is powering the chips.
I understand, but if all the chips chirp at the same time,
There's an anti-collision.
there is.
There's an anti-collision. And all RFID uses some sort of anti-collision, whether it be slotted aloha or whatever. They've got some sort of way to do anti-collision. And for 15693, I actually don't know what they use. But they have a way to back off so they can do a very good reading. Yes, sir.
So those standards, do they define just the MAC or go via MAC?
I'm sorry.
The layers of the, do they define the door layers or just the?
Define the door. I'm not.
The lower side layer.
The ISO layer.
The MAC design.
Oh, there's the ISO standard is about yay thick, and there's 8. Last I looked, there were 8 parts. So it defines it from the physical standard to the inductive standard to the crypto to the modulation scheme. But
So it does define the modulation.
it defines everything. Even things that are called ISO standards don't always follow the standard. It's kind of the world we live in. Standards aren't standard. So UHF tags. UHF used to be like TV and VHF. Well, UHF is now used for RFID. The idea behind UHF was to do very, very fast product identification. When UHF first came out, the neat thing about UHF is not an inductive tag. This is an oddly shaped dipole, believe it or not. And you have all sorts of weird and wonderful ways that people build these antennas. Somebody, a good friend of mine, always said, designing a good UHF antenna is akin to black magic. You have to understand the art of designing those antennas. So these tags were built so that you could have basically shelves full of products or a rack full of clothing, and you could go with an RFID reader and read everything in that rack or everything in that shelf almost instantly. Walmart was promising that they would be putting out billions of requests for these, and they were going to force all of their vendors to use RFID and get the prices down to a penny or so a piece. The problem is you're competing with a barcode, which is much sub 1 penny. But the idea was to basically identify every single product out there. And there's something called the EPC Gen 2 standard, which allows this huge number to be segmented into different pieces. And the idea was there are more numbers in this identifier than there are atoms in the universe, so we should be okay. And inventorying images like this have a great use for RFID. Problem is, at 850 to 950 megahertz, your body completely shields UHF. So water completely shields this. Plus, it's not very friendly with metal. So they kept using pictures like this saying, we can inventory this immediately. But this is a bad example, but they kept using it. That's what they did. I'm sorry, you had a question.
Yeah, so with that second kind of tag, and I didn't get the type, but if you have a
UHF.
Okay, so if you have a box of 10 items,
Yes.
and you would look at each one has a unique serial number.
Each one can.
Yeah, if they coded in the tag, if you use that kind of tag.
Absolutely.
Excellent.
Absolutely. So a great place to use this sort of technology is in clothing. So there are millions of tags so say you have a hotel and you've got 1,000 pieces of laundry that are going through every single day. And the laundromat that's doing your laundry is also doing somebody else's laundry. So they can basically say, okay, here's 1,000 pieces received. On the out end, they can say, here's 1,000 pieces shipped. Oh wait, we've got 1,001, and we're missing that one specific tag. How do we find that one specific tag? And you can find that. So they're really, really great use cases for UHF and for RFID. So the way most of these tags work, and this is true for LF, HF, and UHF, is there's some sort of inlay created. Sometimes it's a wire coil, sometimes it's a printed copper or printed silver coil, and then it's joined to a chip. And it's sandwiched in something, some sort of substrate.
So is the identity of that particular tag embedded in the shape of that screen?
There is no identity information that is tied to the antenna. It is all in the actual chip.
What's the antenna design?
Black magic. And I'm not just saying that. There have been some really great RF engineers that create really horrible antennas. And there are people that have no engineering background at all that can create fabulous antennas. And some people just have a feel for what's going to work, where they intuitively can see something.
If you subtract off the business value of what the tag is, what's one of those chipped antennas worth? You know, assuming it's not one with a lot of RAM in it.
It's a small piece of silicon. So what is a small piece of silicon worth? It's just sand. So you get out of a wafer, you're going to get 50,000 chips. These are so small. So whatever the price of a wafer is, maybe $2,000, $3,000 divided by 2-3 cents. It's just a chip, but yeah, what's the price of an Intel core chip? Probably 30 cents of silicon. How much do they sell it for? A lot more. They come in. UHF has been used in all sorts of really extreme environments. So they use UHF. So UHF also doesn't work well attached to metal, but there are ways you can get around it. You can actually use the metal as part of the antenna. But there are lots of people that have actually built RFID chips. They can work in extreme temperatures, things down to about -40. Below that, the circuitry stops operating and then operates to about 70, 80 degrees C. But again, above that, you can start melting. You start melting the copper, which is a problem. So, and you can make tricks so that it'll operate higher temperatures and lower temperatures. But again, it's an art trying to figure out the right tricks for how to do this. And ski resorts. Funny you should ask. So my company actually does uses RFID for identity management. It's one of our commercial off-the-shelf products. We tie into their ski resorts back-end systems, and so they'll put it inside. The great thing about ski resorts is every single one of those people is wearing fuzzy jackets. So those RFID chips don't get right up against their body. So they're almost always, if it's a quarter of an inch off the body, you can actually read it pretty well. If it goes right up against the body, it's dead. So what they do is as people queue up, you have one of our handheld readers, and as they walk up, beep, and their picture shows up. You can see, and they walk right through. They have it set up in other places where you walk up and it actuates a gate. You walk right through the gate. One of the neat things is just because you have an RFID chip like this on it's basically a silicon chip. You can build it onto a circuit board, and these circuit boards can be built to withstand very high temperatures. So they make a lot of metal mount RFID tags directly out of the circuit board, and they'll use a very thick circuit board, so you'll 1/4 inch, and that's your RFID tag. You just print it on the circuit board, and you're done. Kind of neat.
one last thing on the ski thing, is that UHF or is it?
There's both. Again, you can use foam to get that extra space off of metal or off of water. This is kind of what UHF readers, and these are antennas up here. These are readers down here, and this is a combined reader and antenna. Most often in the field, you're going to see readers like this, and then you have cable coming out attaching to the different antennas. This is an access control one that's tracking people as they go in and out of an elevator. You have portals. Again, these can be used very well for libraries, but if somebody takes their iPad and sticks it over their book, you're not going to read it.
So the difference in the frequency, is it because of data rate, or is it the range, or is it the cost?
Yes. Yes. And there are a bunch of handheld readers that can read not only UHF, but HF as well. One of the interesting things is with a barcode, you shine that light, you know exactly where that light's read. If you're in the field and you have an RFID tag on all of this and you read it, you're going to read not only these tags, you're going to read these ones behind those. You're also going to probably read a tag behind you. So it makes it very difficult sometimes to know what tag you're trying to, basically to isolate and singulate those tags. So people come up with different ways to singulate UHF tags, just because it'll read all of these tags like that, super duper fast. There's a really neat reader out there called the X-Ray that's only been out for about a year. This reader actually has 54 steered beam antennas. And the cool thing about this is as you walk, it can actually, so it will replace one of these tiles up here, and it'll cover about 100 square feet below it, maybe 15 by 15, 225 square feet is the standard. So, and because it's got 54 steered beam antennas, it can actually identify within about a foot where those items are. Now, again, if you happen to be above that tag, it's not going to be able to read it. But for item tracking, it's a pretty fabulous technology. Or if you have it on a badge, and that badge isn't right against your chest, you can use it for directionality, whether you went through a portal or not. So now I'm going to discuss active RFID. So these are tags operating between 433 and 2.45 gigahertz. So coming back to Zigbee, I think Zigbee is actually at 433, but I could be wrong. It's been a while since I've used it, so I'm not keeping up with it. My brain's kind of full. So battery powered, because they've got batteries in them, higher tag costs. These tags are generally designed to last anywhere from a year to 5 years on a battery, with somewhere around a 10-second ping. You can make it last longer. You can make it ping more frequently, which will kill the battery faster. And again, we're already using these things. I thought I was at a different slide, so I'll get back to it. So they've got long range, different form factors. They can look like an ID badge. They can be mounted to cars. Hospitals use them. One of the big issues with hospitals, so there's a company here in town that does active RFID. Aeroscap's another active RFID company. AwarePoint's the one in town. In hospitals, they will put this on hospital equipment so they can say, where is this equipment? Because if a doctor needs a piece of equipment, every minute is a significant amount of money in a hospital environment. So they have readers in every room, and they can track where things are, find them instantly. That type of system is called RTLS, Real-Time Location Sensing, or systems. Some of these systems have their own readers. We've got one over there. Alec? Yes. So, Mark, can you hold up the active reader over here?
Carefully.
If you have to be careful, don't worry about it. I want to show the demo first. So this is many active systems can also work over a standard Wi-Fi signal. generally Wi-Fi is a more power-hungry protocol, so they don't use, there aren't too many successful tags that work over Wi-Fi. Ekahau, I think, has the only solution that's really being used over Wi-Fi. Could be mistaken there. This is what an active antenna looks like. Just a standard dipole antenna, very small. See it over there? Very small. You can use active RFID for location tracking. So here, if you wanted to track somebody with a passive tag going in and out of the building, you'd have to have a portal, and they only get about 30 feet max range, often much less. With active RFID, you could have one reader detecting this entire room, and in fact, we have that right now. So Alex over there has an active RFID tag, and over here, you can see a computer that's got a yellow screen on it. So if Alex were to walk closer, and Mark, I think it's disconnected. Okay. As he gets closer, the signal gets stronger, and it should go to green. There we go. So you can tell your location. So you can kind of poorly triangulate where something is. If I've got all these people in this room, and I set up my distance from there to there with all these people, it's going to give me a different RF baseline than I would have if the room was empty, or if I have equipment moving through it. So you can kind of, sort of get a good idea of where an item is. You can almost always get it down to the room level. Getting it down to an actual specific location is much, much more difficult.
Yeah, what's the cost difference? I'm just curious. Like, is it a factor of 10 or something like that, or between passive and active?
So those tags cost us about, we sell them for about $30 depending on quantity, low volume. And that's talk to Aeroscout and some of these, I think they're selling theirs for 50 or something like that. They're more expensive. They've got prettier software than we do. So they give you nice 3D software that shows these different, but this is kind of an RF map of a building. So if you have a reader here, you can see the RSSI. RSSI is relative signal strength intensity for those of you that aren't engineers. And you can see it's not smooth. You have a bump here and a bump here that are both high, and then as it goes further out, you get these weird topographical RF map areas. Very, very similar to Wi-Fi for those of you that have Wi-Fi knowledge. But by having multiple of these readers overlapping multiple maps, you can actually get a pretty good idea of where something is. Usually about 3 meters. We like to just do room location because we find that's usually good enough for those. If you're missing a piece of equipment, you know that it's in this room, you can find it pretty well. And use your cost down. You had a question here?
You're talking about the difficulty of using RFID to locate something. Has there been much cooperation or overlap between RFID and GPS?
GPS is a time difference as opposed to an RSSI. So it's basically an estimation problem. So my background was in parameter estimation using Kalman filtering. And basically you're talking something that has a direct correlation time to something that has an indirect, nonlinear correlation in a changing environment. It just makes things a lot more difficult. There are lots of people that are working on this problem, but they're just inherent limitations because your RF environment gets affected by anything that comes into it, and anything that leaves it. So it's not standard. Whereas your time delay, God has the time.
Okay. Yeah, I understand that, but I would think with GPS, that would give you a better fix on the where.
Well, I'll get there.
I was just going to ask, so on those tags, so say tracking in a hospital, tracking equipment, what's the, on average, I know you said, 2 to 5 years for an active tag, but really, on average, because you don't want a tag dying in the field necessarily, you do want to replace
5 years usually.
5 years.
They'll usually last 5 years, and then it'll start sending a battery low signal. It'll last 6 years, and it'll send a battery low signal at 5.
Okay.
you consider the key and luggage tags that are sold now that have a low power Bluetooth?
BLE is one of the technologies that I've been promising myself that I'd actually look into, but as of yet, I've not seen an opportunity to make money off that area, so I haven't investigated it.
The thing that's interesting is that all of their marketing says, well, gee, you know, everybody that's got a cell phone that's running our app is one of your sensors.
I would love to be able to tell you more about it. Maybe one of my, do any of you guys have any knowledge about Bluetooth functionality? No? We haven't had an opportunity to delve into it because it hasn't been a place for us. At heart, we're money grubbing entrepreneurs. So.
The costs are much higher, a lot more silicon, similar to Wi-Fi.
Yeah, and I would assume there's more power, but I don't know, I'm guessing. So coming back to the GPS solution, so for our accent tag on a Hershey's candy bar, kind of blows your profit margin. Especially low margin stuff. And then they started having issues like, well, you can't actually tag cans of Coke. Oh, you can't tag fruits and vegetables. All these things you can't do. So they had this huge, without knowing all the limitations, it was a great idea, but it was a flawed idea at the time. Macy's, we're still optimistic that we can get there. Macy's just announced they're going to have 100% inventory tracking by 2017. Great thing about Macy's is they're all closed. You can actually track clothes really, really well. Somebody looked at it and said, yes, Walmart failed. Tag prices now, when you're talking millions of items, you can get tag prices sub 6, sub 7 cents. So it's coming back, and it's coming back to better areas.
Are those the 125 kilohertz? Or are those
900 UHF. They want to improve their operations as well. They want to be able to do a very fast inventory of what they have. They want to know what's been stolen. They've lost stuff. This is your privacy invasion upgrade. So you're having a contactless chip in passports. The very first time that they put a chip in a passport, they didn't have any two-way security. It had an answer to reset. You could query the data immediately. So I could walk right up to Corey, bump up against him. I could read not only his MRZ, the passport number, I could pull off his biometric, I could pull off his face. I had all the information needed for me to make my own passport so I could be Corey. And I could put my own picture on there. So they've improved that recently so that they force you to read if any of you have been to a place where they've read your passport contactlessly, you'll notice that they still put it down on a reader. They're checking the multi-spectral technologies of the printed stuff. They're reading the MRZ number. That MRZ is coded so they can use it as a key to access the contactless data on the passport. So poorly implemented at first, better implemented later. Chris got to go to Australia to investigate that one. That was fun. Yes, sir.
The 6 to 8 cent tag you're talking about, how much of the cost of that tag is the chip itself?
No, I don't know.
50%, 80%, 10%?
Oh, silicon. So you're talking sub 1 cent for the chip, and then you're talking.
Your example before was the wafer cost $2 to $3 grand, you get 50,000 out of it.
Yeah, I'm pulling numbers out of the air. I don't know the exact numbers off the top of my head.
Do you think you can get sub 1 penny for the chip itself?
Oh, easily. Yeah, they're very, very small fractions of wafer. They're making good money. This is last video. Somebody asked me.
You have to tap the side button.
So I worked for Cubic for 10 years, and I really enjoyed my time there. They've done this more recently, so they've set up RFID, so your phone and your Apple Watch can be used as an
If you approach the ticket barrier with a watch, you have to tap the side button twice to get it ready to scan. And on a phone, you have to use the Touch ID sensor, typically with your thumb, and you have to do this for tapping in as well as tapping out at barriers. When we tried it out, we found for a watch, this is as fast as a normal contactless card. The odd thing though is that on a tube barrier gate is that most people wear their watch on their left arm, whereas the Oyster Pad is on the right hand side. On a phone, it does take longer though to tap in, as there's a second delay whilst it scans your fingerprint before letting you in.
So again, that nobody thought about using a watch as an entry piece. Well, actually, we did think about using a watch as an entry piece, but we never deployed it to keep it. But operation, trying to make things efficient. Back here. So we're just about wrapping up here. So the thing that I want you to take away from this is RFID is a tool. It's not a solution. Great for identifying things. It's great for authentication. There's security that can be built into the chips depending on what you're doing. You can read a lot of stuff very quickly. If you guys all have the right type of RFID tag in here, we can tell that all of you are in this facility, and if there was an earthquake and all of you stampeded towards the door and the left Keegan there in the doorway, say, help me, help me. As everyone walked by, we could actually tell that Keegan was still here in the building. That's actually what my company does. We do emergency evacuation tracking using RFID, tying into security systems. So you can, with the right system, you can use RFID for lots of really awesome purposes. But it's the system actually figuring out exactly what you want to do and what the purpose of that is that's really important. Different technologies are going to give you different capabilities. You're not going to get really, really secure technology on a UHF tag. There's just not enough silicon on there to do what you want to do in terms of having really good crypto. You're not going to get a lot of memory on a UHF tag, usually, unless you're willing to invest in larger silicon, which is going to drive your price up. There are disadvantages to RFID. They can be spoofed, credit cards, passports, we talked about, orientation issues. So if Alex were to stand up with his tag and he holds it straight up, come over to the reader.
It's a little offset.
Okay. So if he holds it this way, he's going to get one sort of read, and if he flips it so it's flat, he'll likely get a different RSSI. So RFID is orientation specific, and there are some people that try to make omnidirectional RFID tags. They work to some extent or another, but there are issues. There's a cost to encode each tag, and you always have people out there that are forcibly trying to damage their RFID chip because they don't want to be tracked. There are people out there. There was a school where they were trying to track all of their students up in the Bay Area. I forget which city. They put an RFID chip in all of their student IDs so they can tell what students came in. Good idea, so know where your students are. The parents went ballistic. You're trying to track my kids. This is the mark of the beast. What? You laugh. It's a reality that there are social implications to using RFID, and there's also the issue that you can be right up here. I can be trying to read Corey's name tag badge, and I think I'm reading it, but I'm actually reading somebody over here or somebody behind me because there's no real directionality for 900 megahertz UHF. A little bit more on the ISO 156 on the 125 kilohertz or the 13.56 megahertz, but again, a little bit of ambiguity. So basically, RFID can be used to improve whatever operations you're doing, almost guaranteed. But first you need to understand the problem that you think it's going to solve, and then talk to somebody that actually knows what those problems are. So I'm open to questions, if anybody has questions. Yes, sir?
Does Samsung have RFID or NFC?
Same thing. So NFC, so the NFC standard was built as to work over 13.56 megahertz and it's built so that it can emulate a tag. It can act as a reader, or it can talk reader to reader. So that's the big difference with NFC. It's built to be either the client, the server, or talk server to server. But I call it RFID. I don't know. Other people might call it different things.
What kind of bandwidth can you get out of NFC?
How much data?
Yeah.
I don't know. I don't know.
I mean, they're talking about sending pictures, and I always
Yeah.
wondered if they used that to establish a connection, and then they used the Wi-Fi.
Again, I've never seen actually a way to make money off that, so I've not gone into that.
Good.
Yes,
So the 39 feet that you mentioned for passive RFIDs,
39 feet for you.
39.
Yes,
is that for completely passive or for what
completely
they call
passive.
it
So,
semi-passive?
and to be honest, that was with one specific handheld reader that was well tuned, with one specific tag that was well tuned, that we were able to get 39 feet. Yes, Chris?
The maximum data transfer rate of NFC is 424 kilobits per second.
That's good enough to get a picture through pretty quick.
Yeah.
Yeah, but what, they're submodulating up on 13.56 megahertz. Yes, sir.
Question regarding the anti-fraud. How do you check?
The anti-fraud?
Yeah.
Okay.
In practice, how do you check? You read that outside and go to website to check.
So this is beautiful. So, Kelly, you want to take this question? Kelly just actually implemented the solution for a clothing company.
Sure. So there's lots of different ways you can on the UHF tags or LM tags have different memory sectors within the tag itself. Each sector can have its own key to access the memory sector. So without the key, you wouldn't be able to access the actual memory and decrypt it. You would use any standard, typical AES 256 or typical cryptography ways to make sure that no one else can get access to it.
So you do that in
Yes, correct. So, in order to access the memory blocks, you would have to know what the code is. So if you're on a website, and the website will have to send a key over to be able to log in.
And the crypto can be implemented both internal to the chip. There are chips that have lots of capabilities. There are chips that have lower capabilities. So sometimes there are specific crypto chips. They're more expensive. Yes.
What kind of percentage of failure rate on the chip itself?
So
many years ago, like in 2010, I heard about 5 to 6%. Roughly. Is that what
I would go out of business if we had 5 to 10% failure rate.
No, 5 to 6%.
Yeah, I would go out of business.
I mean, I was heard about it that time. How to prevent the damage?
The issue is, it's a chip with an antenna. So if the silicon gets damaged or the antenna gets damaged, both of those things can destroy the chip. So when I was working at Cubic, we had literally a box of broken tags that had come back from the Smart Trip cards. And it was hilarious. So somebody sent us back their card and said, my card doesn't work, send me a new one. And the dog had chomped through the card. We had somebody else that sent us back their card and said, I put a punch in it so that I could put it on my badge. So they punched right through the chip.
What's the probability of that?
We had other people that we had a client that basically took a card, and it was a label in this case, and they bent it in half so that it would fit in a nice place in their wallet. Well, the problem was it's a coil, right? So it needs the magnetic field to go through it. And you bend it in half and you get this C. And the mutual inductance of a C is pretty low. So a lot of the stuff that happens is if there are failures, there's no accounting for what the stupidity that people will put your stuff to, and that's
Yeah. Another question, how to prevent the damage of the chip when you have it inside the tag, especially the paper tag for the government industry? Because
education. Education. Or you put it in a block of plastic that can't be bent.
No, impossible for the government industry. It's basically clothing, it just has a certain paper, and there's the chip tag.
Have you come across any of these that work better underwater? Are there any that work well in I have a friend in Scripps who uses tilters, and they're awful battery life.
There are people that say that they're going to get, that they can read UHF underwater. ISO 15693, I would bet would work underwater, but I haven't tested it, so I'd have to check. We did a solution for a mushroom farm where we took an embedded tag and we put it, they wanted to make sure that it would operate in highly chlorinated water because they're washing their baskets every day. So we literally left this thing in chlorine for a year to see if it disintegrated, and it didn't. And we could actually read it inside the chlorinated water. So, but again, you have to be pretty close to it. So it's a matter of how much power you're pumping out in a lot of cases. You need to be able to energize the tag, and whatever you're around is sucking that energy out. The water tends to suck RF energy out of most, which is a very RF impenetrable medium.
What's the typical way to attach the antenna to the chip? Is that it's not wire bonded?
Sometimes it's wire bonded, sometimes it's direct.
Tap bonded.
Tap bonded, yeah.
Is there a list available of the most reliable tag manufacturers?
For what frequency?
900 megahertz generation 2 type tags.
Duration, I'm not familiar with that.
Yeah, that's the
EPC Gen 2, yeah. Us? There are really 3 vendors out there. One is that make the chips. So the Alien, and they've been around for a while. They've all been around for a while. Alien, Impinj, and NXP. NXP used to be Philips, and NXP just got purchased by somebody else. Qualcomm. So yeah, the big brother's starting to swallow everybody up. They all make chips. They all go out to different manufacturers. If you have specific questions, there's hundreds of people out there that actually make tags. Our company actually doesn't make tags. We work with lots of different people, and we order different tags for the right purpose, and we know what the different tags are. If you have a specific requirement, just give me your card, and I'll have one of our guys call you, and we can help you out. I love questions that might make me money. Yes?
Reminder for raffles and the survey.
Yes. Has everybody given their
Survey.
card to Egan?
There's a raffle for Starbucks gift card. So you can give me your business card.
And we have at the center of the tables we have surveys. If you can fill those out and let us know what we did well, how we screwed up, what we can do better. Not only would it help us, but we'll share the information back to the IEEE so that they do these meetings all the time. So I'm sure